In the next step of building our RC car, we'll use Raspberry Pi Pico to control both the motor and the steering servo. The motor will be driven through DRV8833 motor driver, and by the end of the video we'll connect all of this together and power from this USB power bank. On the Pico we will be running FreeRTOS. It makes it much easier to manage multiple tasks, which is perfect for this kind of a project. We'll start writing code for the Pico. We'll use OpenAI codecs for that. And at first we'll test everything carefully with the multimeter to make sure we are not burning any components. Rule of thumb, do not connect anything to the board when this board is connected to our computer USB. Once our software is working properly on the device, we'll connect everything together, all these components. We're going to power it from the outlet, and then we'll connect our battery. Let's get into this. To kick the project off, we'll start with a template. This template comes with a FreeRTOS already configured. The template also comes with Bluetooth already configured, and it has a code to blink a GPIO15. This is very useful as a smoke test when we go to deploy the code to the device. We'll start with configuring CMake and then compiling the project. After this is done, we are going to upload the project to the device. You can see the serial output from the device in case you need to debug. Now we can check with a diagram where GPIO15 is and where the nearest ground is. And with the multimeter we can see that the GPIO15 is changing from high to low. After making sure that the template is working, we can ask codecs to make the changes we need. We are giving detailed instructions to codecs. We want our motor to reverse direction every 5 seconds, and we want our orientation for the servo to be flipped every 5 seconds as well. We are going to instruct codecs that we are using DRV8833 as our driver. The changes are done, and these are the instructions which pins needs to be connected and how. From our previous video, we know that DRV8833 requires extra pin, which is end sleep. We are going to tell codecs that this change is required. Codecs agreed with us, no surprise, and this is our final pin out for the project. In addition, I forgot to provide servo details in very first prompt. We are going to do it now. We are going to do a quick code review to understand what the changes are. So the changes are as expected. Our code starts with a new task, and this task is changing both the motor and the servo. And this main loop of our task, basically it runs forever and every 5 seconds flips both motor and the servo. Code changes looks good to me. We are going to connect the device back to our computer and upload the changes to the device. And we can see the new logic is working. Every 5 seconds we see the motor changes the direction and the servo changes the orientation. Same as before, to see the level on the GPIO15, the black goes to ground and red goes to the pin 15. We can see level changes every 5 seconds. Now we're going to connect motor driver. We'll follow the same schema as we did in the previous video, according to the instructions from codecs. To power the breadboard, we are going to use USB from an outlet. Here is the breakout plug for USB. It has positive and negative signs. Red goes to plus and black goes to the ground. We're connecting multimeter to channel A output on DRB8833. This way multimeter plays a role of the motor. Now we connect the power, and we can see the motor direction changes every 5 seconds. Now we can connect our servo. Servo has 3 wires. Yellow is the control, and red and black are the power. We are going to add some tape to the motor to make it easier to see the direction. And we are connecting the motor instead of the multimeter. After the power is on, we can see that both motor and the servo flip directions every 5 seconds. In the next video, we are going to add a Bluetooth control, so we can control both direction and speed of the motor and orientation of the servo.